Okay, we are going to look today at two specific situations that can happen when we've got quadratics. So the first thing we're going to look at is what happens when a is not 1. So that means in front of the x squared we've got like a 2 or a negative. And then we're going to look at what happens when we only have one x-intercept. So these are both two specific situations. They're a little bit different, but they're not bad. So let's take a look. You should have in front of you some notes that look like this. Okay, so we're going to start with what happens when a is not 1. So you can see, remember, standard form of a quadratic is ax squared plus bx plus c. So here, your a is 2, and your b is 12, and your c is 16, right? So this a value is not a 1. And what that means is we are going to have to do an extra step, all right? It's not going to make a huge difference, but we are going to have to do something different. So the first thing you're going to do is we're going to factor out the common factor. Now the common factor is hopefully the a value. It's not always common, but for right now it will be. So what I mean by that is you can divide 2 obviously by 2, 12 divides by 2, and 16 divides by 2. So they all have that in common. So we are going to factor that out. So that means we are going to rewrite this to be y equals 2, and I'm factoring that out, so I'm going to put it out in front. And then what I have left is x squared, 12x divided by 2 is 6x, and 16 divided by 2 is 8. So I factored out a common 2. Then the next step is we're going to factor this part down to brackets. So we're going to factor a step further, and we're going to be like, okay, well, y equals 2, and now I'm going to factor down to these brackets. Well, what two numbers multiply to 8 and add to 6? So 4 and 2. So just so we're like super clear here, this function, and this function are all the exact same. They are just different factored versions of each other, but they are all completely equal. All right, next up, we're going to find the x-intercepts. We are going to do that from here. We're going to use this version to give us x-intercepts, and we are going to use the brackets. So I'm going to just kind of like normal, I'm going to take my x plus 4, make it equal 0. I'm going to make this bigger for you guys. And then I'm going to take the x plus 2 and make that equal to 0. Because remember, when I look for x-intercepts, I replace the y with 0. So that's why I did that. Now you solve for x, move your 4 over, and you get x equals -4. Move the 2, and you get x equals -2. All right, x-intercepts, done. Now, our y-intercept, our next step is to find the y-intercept. Your y-intercept does not come from the factored versions. No. It needs to come from standard form. So your y-intercept has to come from standard form. So if you look up there and you replace your x with zeros, you will find that y equals 16. So your y-intercept is at 0, 16. So it came from, we call this is either called standard form, or since it's the first function we gave you, we call that your original function. All right, now to find the axis of symmetry, again, we're following just normal stuff. We're going to take our x-intercepts, add them together. So we're going to say x-intercept plus x-intercept, and we divide by 2. So in this case, that means we're going to say -4 plus -2 divided by 2. Well, -4 which is basically minus 2, so that's negative 6 divided by 2 equals negative 3. So my axis of symmetry is at negative 3. Find the vertex. When we find the vertex, we're going to plug the axis of symmetry into our function. Now, you can use any one of these. Remember, these three functions are all the same. I tend to use the original function because it's usually the easiest, but you don't have to. You can use whichever one you want. I'm going to use the original function. So my function said y equals 2x squared plus 12x plus 16. I'm going to plug negative 3 in for all of those x's. So 2 times negative 3 squared plus 12 times negative 3 plus 16. All right, aren't you glad we practiced this? Negative 3 squared is 9. 9 times 2 is 18. 12 times negative 3 minus 36 plus 16. 18 minus 36 is negative 18. Negative 18 plus 16 is negative 2. So the y is negative 2. Therefore, my vertex is at negative 3, negative 2. Now, in case you don't have that down yet, the axis of symmetry is what gave me the x of the vertex. In the y, I plugged it in and found it. Okay? So, when it's time to graph, here's what you're graphing. You're going to come graph the vertex, you're going to graph your x-intercepts, and you're going to graph the y-intercept. And then you're going to connect them so they look like a U. So you've got an x-intercept at negative 4, one at negative 2, a y-intercept up here at 16, and a vertex at negative 3, negative 2. So when we connect these together, we make them U-shaped, and they look like this. And we're done. All right, let's look at another example. So, oh dear, what's happening here? All right, let's look at this example. This example also has a not as 1. So look, what do we have as our 1 here? We've got a negative 1. So negative 1. So that needs to be factored out. So we're going to factor out a negative 1. So if I factor out a negative 1, that means I'm left with x squared. Negative 2x divided by negative 1 is plus 2x. And 3 divided by negative 1 is negative 3. So I factored out my common factor. Next, I'm going to factor to my brackets. Remember, that negative needs to stay in front. And we're only going to factor this part. So what multiplies to negative 3 and adds to 2? So x plus 3 times x minus 1. All right, find the x-intercepts. Again, all we're going to do is replace our y. We're going to sub in a 0 for y and make that equal to each of our brackets. Solve for x. So we have negative 3 equals x and 1 equals x if we rearrange. There's your x-intercepts. Find your y-intercept. Remember, your y-intercept is going to go back up to the original function. What's the y-intercept there? If I replace my x's with zeros, my y-intercept would be 3, which is that number at the end, your c value. Your axis of symmetry. The axis of symmetry comes from your x-intercepts. So I'm going to say negative 3 plus 1, and you divide in half. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. The vertex. The vertex comes from using your original equation again. So y equals negative x. X I said is -1, right? That's from here. Squared minus 2x. So 2 times -1 plus 3. So be careful. -1 squared is 1 times a negative, -1. -2 times -1 is 2 plus 3. So y equals -1 plus 2 is 1. 1 plus 3 is 4. So what does that mean? That means my vertex is at -1, 4. Now, we're going to graph this. When we graph this, we are going to graph our x-intercepts, the y-intercept, and the vertex. Then, because we had a negative a, that means that our graph is going to be opening down. It's going to be a frown. So let's go graph this stuff. All right, so we have an y-intercept, or an x-intercept at 1, an x-intercept at -3, a y-intercept at +3, and my vertex is at -1, 4. This is opening down because it was negative. So I'm going to make it open down, and it's going to look just like that. See? Not too bad. All right. So this is what happens, how you handle things when you have an a value that is not 1. You have to take the extra step of factoring out the a value first. All right, now flip over, and this should be our final example. So this is what happens when we have one x-intercept. So a lot of times, this is what it looks like. See how it says y equals x plus 3 squared? Well, squared means that you're multiplying something twice, right? So that's the same as writing x plus 3 times x plus 3, right? Or I could multiply that even further, like x times x is x squared, x times 3 is 3x, keep going, 3 times x is 3x, and 3 times 3 is 9. So really what I've got, if I want that in standard form, I've got x squared, 3x plus 3x is 6x, plus 9. So kind of like what we were just looking at, there's 3 different ways to write this thing. It could be written in any 3 of these formations, and they are all equal to each other. They are all the same. This standard form is really important because it tells us about our y-intercept. But when you have it factored into brackets like this, do you see how they're twins? They're both x plus 3. That's like your red flag that's telling you you've got one x-intercept. When you've got twins, you've got one x-intercept. So the x-intercept is really simple. It is x plus 3 equals 0, right? Replace your y with 0. Solve for x. X equals -3. Well, since they were twins, it's going to create what we call a bounce at -3. So that means, come down here on your graph, we're going to plot this x-intercept at -3. And since they're twins, there's 2 of them, it creates a bounce. So this is going to kind of go like this and create just one x-intercept. Now, let's figure out where your y-intercept is. The y-intercept, we needed to look over here at standard form. So our y-intercept is at 9. This. It bounces on the x-intercept and goes up and hits the y-intercept. That's how we create one x-intercept. Now, where is the vertex? Duh, it's right here. The vertex is at -3, 0. This is super easy because it's the same as the x-intercept. So it kind of looks complicated, but it's actually pretty easy. Come back up here to the y-intercept. We said our y-intercept was at 9. And then the axis of symmetry, well, even better, axis of symmetry, remember, is where it gets cut in half. Well, where is it being cut in half? -3, right? The axis of symmetry is always part of the vertex. So it's really convenient when you have this because your vertex, your axis of symmetry, and your x-intercept are all the exact same thing. So that's really nice. Okay, so that's what that looks like. I hope that all made a lot of sense. Okay, good luck.